For some of you, this may be old hat. You've been exposed to this whole idea of an atom and with the protons and neutrons in the nucleus, electrons in the cloud outside the nucleus, and electrons at different energy levels. But for some of you, this is really new, so just bear with me. Another thing I want to talk about is this idea of an ion, and I've actually already alluded to it before. We picked on carbon earlier. Carbon is atomic number 6. So this is the nucleus of a carbon atom, and we could put neutrons in here. One isotopic form of carbon is carbon-12, very popular. So there's my nucleus of a carbon atom, and if it's neutral, we said it has 6 electrons. 4, 5, 6. And they're at different energy shells. But my point here is that atoms aren't necessarily always neutral. And the reason they're not neutral, this one's neutral because it has the number of protons, which is what has to be stuck in the nucleus of an atom, is equal to the number of electrons. Now, electrons can come and go. Okay, so this actually is a moving target. This is fixed. Okay, so let's just say that our carbon atom, this is probably not a really good example, but let's say that it picked up 4 electrons. Okay, so now it's still got, what, 6 protons, and now it's got 6 plus 4, or 10 electrons. Yowza. So again, this is kind of a strange example, but do you guys buy this? That this actually now is going to be a -4 charge. It is now going to be what we call an ion, specifically an anion. So that's just one example of an ion being formed. So the metals actually, unlike the example what I showed you with carbon, metals tend to actually lose 1 electron or 2 electrons or 3 electrons. And we're going to try to think through this, but as a metal loses an electron, can you buy this, that now it actually is electron deficient? So now it's running around with positively charged, and we call that a cation. And this is an important word right here. A cation, not a cation, a cation. So for every electron it kicks off, it bumps up a +1 charge for every electron it kicks off. Non-metals, like carbon, tend to gain electrons, and for every electron they gain, then they're electron rich, and so they become a -1 charge for every electron it gains. And instead of a cation, this ion is called an anion. So we have cations are positively charged and anions are negatively charged. All right? Cool. Well, that actually is related to something we've recently talked about. Or we talked about, I don't know when it was, what part it was recently. But remember, so we have 1A elements, 2A elements. Remember, these go up and down. These are groups, 3A, 4A, 5A, 6A, 7A, and 8A. And one of the things we said is that their group number says how many valence electrons they have. Valence electrons are important. They're the outermost electron. And let's pick on nitrogen this time. Here's nitrogen. And these kind of bands right here are showing you where the 7 electrons in the neutral nitrogen atom are. And notice we have 5 valence electrons. That's the group number. Okay, we have 6 valence electrons here for these 6A, oxygen and sulfur. 7 valence electrons for, we call those the halogens, 7A, group 7A. And we have 8 valence electrons beginning with neon. Okay, for we call these guys, the rare gases, remember. Okay, so we're all good with that, right? Well, here's the deal. These groups these elements will tend to want to get a set of 8 valence electrons. Now, for the metals, I'll go ahead and kind of circle 1A and 3A. Okay, for the metals, what's easiest is to kick off their valence electrons. So for that reason, the metals, actually the 1A, beginning with lithium and sodium, the 1A will kick off their 1 valence electron, okay? And if they kick off an electron, they're electron deficient and they become positively charged, specifically since it was 1 electron, they run around with a +1 charge. Over here, the 2A kick off their 2 valence electrons, and now they're less 2 electrons than they have protons in their nucleus, and now they are a +2. Beginning with aluminum, because boron's not a metal, but beginning with aluminum and downwards in this group, it will kick off its 3 valence electrons, and now it will be a +3. Okay, so these are all what? Cat ions. I like it because I think of the cat, the kind of the T, as being a plus. All right, so it's all about valence electrons. Now these ions are what we call mono, as in one. These are just monoatomic ions that these are going to form. Okay, so let's look at, let's look at now the nonmetals. And I actually, if it's okay with you, I want to start with this guy, 7A. These are our halogens. And it's all now for them, see, 7A means they have 7 valence electrons. Oh my goodness, they would have to kick off 7 electrons? I don't think so. So instead what they do is they just add 1 more electron. Okay? And if they add 1 more electron, they get a complete, what we say, octet. So now instead of 7, it's 8. But now fluorine and chlorine will do that. We'll add 1 electron to each of them. And so in doing that, they are rich 1 electron. They have 1 electron more than they have protons, and they become negatively charged, specifically a -1. The other 2 groups I want to take a look at is 6A, has 6 electrons, valence electrons. You can see 6 valence electrons. And so to get 8, we're going to add 2 electrons. And if we add 2 electrons, then actually they're going to run around with what? A -2 charge. That's what these guys are. And then nitrogen and phosphorus, 5A. You can see here they have 5 valence electrons. And they pick up actually 3 electrons to give them 8. And if they pick up 3 electrons, now they are negatively charged, -3. So remember that these are anions. These are negatively charged nonmetals. All right, there you go. So here's a few questions for you. I'm hoping this will kind of go seamless. So to me, to answer these questions, you're going to have to find these elements on the periodic table. And when you do, you're going to see they fit into the category that I just talked about, being a 1A, 2A, or 3A metal, and they're going to lose, they're going to lose a valence electron, 2 valence electrons, or 3 valence electrons, become a cation, or they are going to be a 7A, 6A, or 5A nonmetal and pick up electrons. So go ahead and answer these questions.